Hello, welcome to another video in this series. We will continue discussing database exploitation. The purpose of this project is to explore different ways we can sort of alter or attack databases so we can take certain functionalities and leverage them to give us other unintended functionalities that are potentially useful in certain scenarios. So a bit about this database implementation. It's a bit different than a lot of the other ones I've covered up to this point. Starting off, it is a Python API. All of the data gets stored in files. Databases are directories, and tables are comma-separated files, CSVs, stored in the database directories. And there is a link to the project if you want to go take a look at it. So a bit about this attack. It is a bit different than a lot of the other attacks I've been able to execute up to this point. Starting off, it is an extremely simple attack. It's so simple I kind of struggle to even call it an attack. So tables are stored as CSV files, and tables are referred to via their file name. So let's say if you had a table named table 0, the actual file would be called table 0. So what we can effectively do is we can just create a symbolic link to one table and have it named something different and stored in a database directory. And then we can leverage that symbolic link to execute queries against one table when in reality we are executing queries against another table. So in reality, this would allow us to create a table without directly querying it. This could be potentially useful in an instance where we're able to interface with the database and only query one table, but there is another table with data we want to see or alter, and we can somehow create symbolic links. So now to demonstrate this attack, it's an extremely simple attack. Since tables are stored as files, we are just creating a symbolic link to one table, which is called something else. Since tables are referenced by their file names, we can leverage that symbolic link to execute queries against one table, when in reality we are executing queries against another table. So we have three separate Python 3 files for this attack, since the database implementation is a Python 3 API. The first createTable.py will create the database test, will create a table within that database called table 0, and then insert 3 records into it. The second Python 3 file will simply just print the entire contents of table 0, and the third Python 3 file will print the entire contents of a separate table, table 1, insert 3 values into it, and then print its entire contents again. So let's start off by actually creating the database in table 0. We see here the database and the table have been created. Let's go ahead and view the contents. Yeah, we see that there are 3 records here. We also see that in the CSV that's stored there. Now let's go ahead and create the symbolic link. So you can see that symbolic link is there. Now let's go ahead. Notice that the symbolic link we created was table 1, which this file up here, insert table, that's the table that's being referenced there. Let's go ahead and run that file. So you can see starting off, the records are x0, x1, and x2, which are the contents of table 0. And then we can see after that, we insert the values. There are 6 rows there. And then when we go ahead and view the contents of the original database, we see that it got changed. So as we have seen there, we were effectively able to execute queries against one table, when in reality those queries are being executed against a separate table.